something that's spin stabilized, it doesn't perturb. So you can see it there in the image right there. IMAP is
There
spinning
we
up.
go. That's that 4 revolutions per minute we were talking about. That is not something that is wrong. That is intentional. And you're looking forward. Any moment now, we could have separation of the IMAP spacecraft.
That is a pretty cool image right there.
IMAP deploy confirmed.
There we go.
We have
IMAP has
deployed.
separated, beginning its mission to map to the solar frontier and reveal how the sun shapes our space environment.
Go IMAP.
You spin me right round, baby, right round. Like a record, baby, right round.
Yeah, there you go.
That's a great view.
It is. It's a great view. But the primary reason we do need to spin stabilized, though, too, besides the angular momentum reasons, right, is it gives us, when we're spinning, we get that full 360-degree view of the medium that is trying to study. So very, very important there.
Now, the second stage has already arrested that spin or stopped the spin.
Correct.
Because the other 2 spacecraft do not need to be spinning. But IMAP is on its way with that ever-important spin. Now we've got another couple of big milestones happening. We should get acquisition of signal. We have a live camera at the location where we expect to see a big celebration. This would be the IMAP Mission Operations Center at Johns Hopkins University Applied Physics Laboratory. Their team there is looking now for the acquisition of signal, and there they are. We heard earlier that they had a lock on signal for the second stage in Hawaii, so their expectation is that we should get that AOS pretty quickly. You're looking at a view at the remaining spacecraft on the stack, which is the SWIFO L1 and Carruthers. IMAP is currently running an autonomous sequence, so it's spring-loaded. As soon as it came off the spacecraft, it started running an operation.
Correct, yeah. So they have all these commands already preloaded in there. And so they're going through now probably their health checks, autonomous health checks, and also trying to dial or phone home in ET parlance. So we're still just waiting for the acquisition of signal, which is very, very important because we don't have a spacecraft, unfortunately, if we don't have acquisition of signal. See them in the corner working hard there.
At the bottom of the screen, there's Kim Ord. She's the spacecraft operations manager.
Yep, we just received word that they did receive acquisition of signal, so go IMAP. That's excellent news.
And that came fast because they had that lock on Hawaii. They also have 2 ground stations from the Deep Space Network in California, so they locked in acquisition of signal. That tells them that IMAP so far is there, right where they expect it.
Exactly. They knew where to look in the sky, and they were primed and ready to actually talk to the spacecraft when it was ready. So kudos to them. I love physics. I love when things work the way they're supposed to work. This is great
and
stuff.
It's a beautiful thing to watch it live as well.
It's a beautiful thing to watch it as well. Agreed. Agreed.
So our next major milestone would be the separation of SWIFO L1, which is still on the stack. That's scheduled for T plus 1 hour and 30 minutes. So we're just about a couple of minutes away from that one.
Correct, correct. And as you commented before, we already arrested the spin rate because SWIFO L1 does not need to be spin stabilized. So that's good news as well.
And Amanda, you'll be tracking the separation of SWIFO L1.
Yes, absolutely. We have had some outstanding views this morning. Congratulations to the IMAP team on that successful deployment and acquisition of signal. Huge milestones and the culmination of so much work to get to this point. Now, looking ahead, we do have 2 more deployments. Next will be SWIFO L1, and that will be followed shortly by Carruthers. As a reminder, SWIFO L1 is the National Oceanic and Atmospheric Administration satellite, and that will be monitoring space weather 24/7. It will essentially act as an early warning beacon for potentially disruptive space weather events. And that's critical because those could impact both communications for astronauts in orbit and also us here on Earth. We're expecting the next deployment in just over a minute from now. You saw during that IMAP deployment that we required a spin of 24 degrees per second. And that's actually the fastest spin deploy that we've supported on Falcon 9 to date. Of course, that's not required for the following two rideshare payloads. You see some great views of stage 2 as well. Now, if you are just joining us, we did have an on-time liftoff this morning at 7:30 a.m. Eastern Time from Cape Canaveral Space Force Station. During that flight, we achieved successful stage separation and re-landing of the first stage booster, completed 2 burns on the second stage to get to this point. And we've deployed the first of 3 payloads. That's IMAP has already been successfully deployed. SWIFO L1 and Carruthers will follow. Now, for the Carruthers payload, this is equipped with a geocoronal imager, and this will be able to detect fundamental characteristics of the outermost layer of Earth's atmosphere. We're listening in for the deployment of SWIFO L1.
There we go.
SWIFO L1 deploy confirmed.
Beautiful separation and successful deployment of the SWIFO L1 payload. We're not done yet. We do have one more payload coming up. That's NASA's Carruthers Geocorona Observatory. We already received that acquisition of signal from the IMAP payload.
So Carruthers.
Now, AOS, as a reminder, this is a AOS, we already had that for IMAP, and that's a critical milestone for these payloads. It's the first communication from the payload to the ground stations on Earth, and it's normal for a spacecraft to take a few minutes to complete a startup and commissioning sequence, but acquiring that spacecraft signal here on Earth is like having our outgoing call answered. And it helps us to confirm the system status and health, so it's great news that we already received that for IMAP, and the AOS for the remaining payloads will come at a later time. So right now, we are just awaiting the deployment of Carruthers.
That's right. We want to let the audience know if you want to catch up on the AOS for SWIFO L1. We've got a code that you can scan with your phone on your screen, and you can find out when they get the acquisition of signal. Again, that's the acquisition of signal for NASA and NOAA's SWIFO L1. In the meantime, we're coming up on Carruthers separation. That one scheduled to happen in just about 3.5 minutes at T plus 1 hour and 36 minutes. There is a shot of Carruthers, the last but not the least of our spacecraft. And now Carruthers is helped by having IMAP off the stack because they get some sunlight on them, which it's important for them to have some heating.
Correct. Yeah, it does reduce some of the strain. Strain is probably the wrong word, but it does reduce the need as much for those launch vehicle heaters, which are keeping their lines open at this point. So the sun is a good thing.
It is, especially when they're hydrazine lines. You want to keep those warm because that's your fuel.
Yeah, we want hydrazine to stay fluid. We don't want it to turn solid on us. So solid hydrazine, bad.
Again, if you want to track SWIFO L1's progress towards acquisition of signal, we got a QR code for you to scan. And there you see it. Just grab that image and you can track NOAA as they seek to acquire the signal for SWIFO L1. Back to Carruthers now. Just a couple minutes away from separation off the second stage, the third spacecraft to separate. So far, great separations for the first two, IMAP and SWIFO L1, looking to have another good one for Carruthers. Carruthers, different in that it was not powered up before launch. It is going to power up after it comes off the rocket.
Correct, and that was always planned for this mission. So the team there at Berkeley, which is going to be taking control of the satellite after separation, they've already practiced this procedure. They already have everything down to the T, how they're going to turn the spacecraft on, perform all the health checks to make sure that everything is optimum and everything's being done decently and in order.
And the team that will be controlling Carruthers is out in the University of California, Berkeley, from the Carruthers Mission Operations Center, and there you see it on your screen. It's about a dozen people there. They have some spacecraft experts and systems engineers ready to do their part at the Space Sciences Lab, which is, by the way, perched high atop the hills on a campus, on the campus there. And they've been around 20 years, but they have one of the best views overlooking San Francisco Bay.
Yeah, it's a beautiful view. I've seen it myself.
Yeah,
It's a beautiful
it's
view.
phenomenal, isn't it?
Yeah,
Out
it's
to the
great.
Golden Gate Bridge.
Yep.
But right now, their eyes are not on that view. They are focused on big screens in front of them. They are off the screen, but they are looking at all the data, looking to see that sign of life that Carruthers has acquired signal. First, though, hoping to have that camera view to watch Carruthers come off the top of this stack, or the side of the stack, I should say. But it will position the second stage, that is. The second stage is putting them in position to release.
Correct, right. So recall every one of these spacecraft had a different orientation that they had to be deployed at. So the launch vehicle's already slewed to the correct orientation for Carruthers to be deployed. So mission accomplished there on that front.
There you have the second stage aiming at the sun. And they're really moving quick away from the Earth. And we're going 27,000 kilometers per hour. So the distance that has been put between IMAP and SWIFO L1 is significant. We are at an altitude of roughly 5,000 kilometers.
Correct, and if you recall, we were looking at the altimeter there on the bottom right screen. We deployed SWIFO L1 about 3,800 kilometers, and so as we're on that escape trajectory I was mentioning earlier, we are seeing our altitude steadily increase as we move to the Carruthers spacecraft also being deployed.
Carruthers, separation confirmed.
Awesome, there we go.
That is cool. Carruthers separating, beginning its mission to capture the faint ultraviolet glow of Earth's outer atmosphere. All three released.
Yeah, congratulations to all three teams. I know this is a big day for all of them. And also congratulations to the LSP team and the SpaceX teams who worked tirelessly to get these missions off the ground. So kudos to all of them.
And the team for Carruthers now going to be very anxious as they look for their acquisition of signal. You know, because the spacecraft has to turn on and run a number of items, but I believe based on the reaction in the room, they may have gotten it pretty quick.
They may
Let's
have.
listen and see if we get an update to the NLM, the NASA launch manager. Unofficially, it looks like they may have got AOS, but officially, we have not heard it yet on our nets. So we may have been seeing the reaction for the spacecraft